You want to expose as many things as possible natively in Kubernetes, just using things like annotation and being integrated into pipelines and the whole idea of shifting left, which means that giving storage as a on-demand resource to developer.
This is DevOps Paradox, episode number 148. Is Kubernetes ready to run databases? Welcome to DevOps Paradox. This is a podcast about random stuff in which we, Darren and Victor, pretend we know what we're talking about. Most of the time, we mask our ignorance by putting the word DevOps everywhere we can and mix it with random buzzwords like Kubernetes, serverless, CI/CD, team productivity, islands of happiness, and other fancy expressions that make us sound like we know what we're doing. Occasionally, we invite guests who do know something, but we do not do that often since they might make us look incompetent. The truth is out there, and there is no way we are going to find it. P.S. It's Darren reading this text and feeling embarrassed that Victor made me do it. Here are your hosts, Darren Pope and Victor Farsick. Now, you may not be aware, but we do some live streams, obviously on the DevOps Paradox YouTube channel, but we also do some live streams over on the DevOps Toolkit channel. Victor, do you enjoy doing those?
Oh, yeah. I like other people drilling guests. Satisfactory.
And recently, we had on a guest over on the DevOps Toolkit live stream. In fact, it was on January 27th, 2022, and it's Nic Vermandé. We had him on to talk about StatesfulSet apps, and we decided, you know what? Let's go ahead and bring him over to the audio side, and let's talk more about StatesfulSet. So, Nic, welcome to the show today.
Thank you for having me. I'm really thrilled to be there. And I love sharing the thing with Victor as well. So all good.
So let's do a quick recap of what we talked about on the live stream. You work for a company called Ondat, formerly known as Storage OS, and you focus on one of the things is StatesfulSet apps. Now, for people that don't know what a StatesfulSet is, can you explain that in 30 minutes or less?
30 minutes. This is too long. Yeah, sure. So there's, at the foundation, I would say that any application needs to store some state at some point. If you have, for example, a 3-tier web application or any application you use on the internet or on your phone, at some point, you always have some data. So an application will have a front end maybe, which is stateless, doesn't store any state, but at some point the data need to persist to disk. So it can be a database, can be a message queuing system. So all those functions, all those services are stateful, which means they maintain a state. And in particular, in the Kubernetes at the moment, we are focusing on databases and asking the question first, is it okay to run a database in Kubernetes? Is Kubernetes ready? And second part is in Kubernetes, those databases will run as stateful sets. Right? So stateful sets in Kubernetes are the object or the resource of choice to run those stateful applications because stateful sets help maintain a stable identity for container. So as opposed to, it's always this pet versus cattle kind of categorization of the workloads you run in Kubernetes. And for some time, we've been saying containers are like cattle. You should treat them as cattle. They are replaceable. And what we are seeing today is more and more customer because of the benefits of Kubernetes in terms of scheduling, high availability, and being able to just run as the de facto cloud operating system. People want to migrate those more stateful application in Kubernetes. And Kubernetes has brought more and more feature to stateful sets, which were probably a bit behind in terms of what they can do in Kubernetes. So I believe that now we have reached a state where I would say it's safe if you do it properly to run databases in Kubernetes, but there are always a lot of concern, a lot of caveats in terms of how you should design them. And this is our mission, basically, our Ondat, so that people can run those stateful application at scale with performance optimization and also bringing enterprise grade, I would say, features to it, things that Kubernetes doesn't do. So replication, encryption, all these kind of things that is not there by default.
When you say that Kubernetes is behind? I mean, stateful applications in Kubernetes are behind stateless. What would be the wish list? What's missing or what's behind?
Yeah. So the idea, what I was mentioning is essentially the different mechanism to ensure that, for example, at any point in time, the strict number of pods are respected in StatesfulSet. In classic deployment, you have the deployment controller, and you have always like a medium state where you can have a surge, so you can have more pods that's expected at any point in time. For example, when you are doing a running upgrade, or you have potentially a failure condition. What was really key is for StatesfulSet to make sure that at any point in time you always have the right number of replicas, so that, for example, if you use an operator that is gonna, let's say, scale the database as you scale the number of pods, then it doesn't kicking. Like suddenly you don't want to, instead of having 3 nodes, you don't want 4 database nodes if that was not scheduled, right? So you want to avoid this kind of corner cases where the number of pods may not be, for one short moment, the real target number that you were expecting, because it can cause unexpected issues in the world of stateful application, because they are pets. They're not cattle. They have a name. They have a special function. So it's really all those features. I think now we're mostly okay. The only thing is probably one of the challenges now, how do you back up? And how do you save the data that is sitting in Kubernetes? So there are companies and products to do it, but I still think this is the early days. Like if I take an example, so we have snapshots today, but we don't have a way that is proper, like this, I would say, Kubernetes, to kind of freeze IOs and do like database queries, and all those kind of things need to be brought like by an external system. So today we are still missing, I believe, some of the components to get to the next stage, which is maintaining this high availability for the data in terms of backup, snapshot, RTO, RPO, to do all those kind of things. Yeah.
Everybody's question whenever we talk about stateful applications, first question I think that everybody asks, okay, should you move your stateful apps to Kubernetes? And I imagine that you cannot give a blank statement with simply yes or no, but what are your thoughts on it? Kind of, should people keep it where it is or move it or something else?
I mean, if you ask me, I'm a big Kubernetes fan, so I would say, yeah, move it. Move it the sooner the better, but do it in a way that is, I would say, plan for it. StatesfulSet is not something that you can deploy just as deployment and just not thinking about it. You will have some issue. For example, if you don't have the right kind of storage, how about, if you run a high performance application like a high transactional database, and you have a lot of performance consumption on this database, then obviously in terms of disk you have to be careful. Kubernetes by default, personally, before really running StatesfulSet, I didn't really care about what kind of storage I had in Kubernetes, because most of the time it was just temporary storage, right? Most of the operation of stateful application happens in memory. So yeah, I didn't care about disk, but actually the moment you start running performance sensitive application in Kubernetes, you have to be careful about what kind of storage, SSDs, NVMe, and also, is your storage replicated? Because fundamentally, Kubernetes, it's it's going to schedule your pod, and the scheduler is going to take multiple, parameters into account to schedule the pod on the right node. But the problem is, if you don't have the storage locally to the node, it cannot be scheduled there, right? So if you have a node failure, your stateful volume, your persistent volume needs to be available everywhere, which basically limits you to NFS, right? As a shared storage. So yeah, the question becomes how to solve that issue, where if your node fail and you use just a local read-write once type of volume, which means locally to the node, how do you make sure that the volume will be at the destination node in case of failure?
And how do you do that? Apart from NFS I understand. You just kind of like mount NFS everywhere and off you go, right? If it's not NFS.
Yeah, so basically it goes through the CSI you're going to choose. And I think this is one of the key features you need to provide people who wants to run stateful application, is you need to pick up the right CSI. Of course, you also need to care about security, networking, all of that. But when it comes to stateful and, persisting data to disk, it's the data. So you have to find the right CSI, the one that is right for you. Of course, at Ondat, we have one CSI and we do all those things, right? Replication, encryption, all of that. We make sure that the volume will be available on the destination node. But of course, we're not the only one. If you go to a cloud provider, you have EBS that can be attached to another node. But again, be careful, EBS, replication, all of that within the same AZ. If you cross AZ, you're going to be running into problems, which makes basically a multiple or cross AZ Kubernetes cluster in AWS quite challenging. If you need to recover the EBS volume at the destination, it may take some time. So you want to be testing all this kind of scenario before adopting a particular CSI solution or a storage provider like, Ondat, EBS, or any of those providers. And you need to do some tests. So if I take our example, we make sure that, we respect the topology key. So you can have a bunch of nodes in one AZ with one topology key, other nodes, other AZ, other topology key. And by default, we will make sure to spread the number of replicas across availability zone, this kind of things. But people don't realize because it's like underlying, the volumes. But yeah, that's, I would say, the main challenge of StatesfulSet and running stateful application. It's about the storage, but also, and I would say the second, it's how do you reduce the developer friction to make this kind of solution transparent to Kubernetes? You don't want to be adding new paradigms or just new way of doing things just because you are doing extra stuff in your CSI, because developers, they don't like that. When you force them to use the tools they don't want to use. It's hard enough to be fluent with Kubernetes. You don't want to add extra steps just to make the storage happen.
I like that part about being easy, right? And transparent. So I assume that when a node goes down, the replica of an application that was running on that node starts running somewhere else. It has all the data that previously had on a different node. And from user perspective, it's almost as if nothing happened. But what's the process? How did all that happen? Not necessarily process from specific tool, but I had my data. Let's say that it's block storage, local storage. So data is lost. Or not, right? But how does that look like from the process perspective?
At the very beginning, the moment a user writes data to a volumes, you need to have synchronous replication, right? There's no other way around. Any write that is committed to your local drive needs to be replicated, which means that your local writes can be only acknowledged the moment all the replicas have been synced and not before. Otherwise, you becomes eventually consistent, which you don't want. So in that particular case, as you write data to your, let's say, primary volume, the main volume, then the data is synchronously replicated to other replicas. And in theory, as I was saying before, because we want to stay Kubernetes, the number of replicas, for example, should just be as simple as an annotation. You just annotate the storage class and you say, every time I'm going to be using that storage class, this is the feature that are going to be, activated. Let's say encryption, fast failover, and 3 replicas all the time, right? At that moment, every time you deploy a PVC from that storage class, you will have all those features available. So you write to the volume gets synchronously replicated to 2 other replicas on 2 other nodes. Now, let's say this host failed. You need to have, so the system needs to recognize that. You cannot really only rely on Kubernetes failure detection because it's going to take about 5 minutes. So in our case, we have what we call a data mesh. So we have some intelligence as part of a control plane that will detect node failure way faster than Kubernetes. And we can just completely fence that particular node and promote a new replica, and the scheduler can happen. So what you must do, of course, is kill the pod, because as long as the pod is pending, then maybe Kubernetes won't start a new one, right? So you need to kill the pod on the source node. And the scheduler needs to be in a situation where it can reschedule the new pod. This is the first thing needs to happen. It needs to be a situation where the pod can be rescheduled. And our scheduler, or any other scheduler that will need to compute the best possible host. So typically this should be the host where you have one replica available that has been promoted as new primary. So essentially, when the node fails, you must have like a promotion event that happen. And at the same time, when the pod is rescheduled, your scheduler, extending the native Kubernetes scheduler, is going to say, look, okay, I've got all the data I need. This pod is currently being rescheduled. The volume now is there. So my preference is to start the pod there so that it's local to the new primary volume. That's one solution, and that would work, right? So the volume is completely synchronized with the other one, the old one, and just is business as usual.
So does that mean, I'm trying to see whether I understand from a perspective of a person who is not deep into it. So some other replica, database replica becomes master. That's where the requests are happening. That's where the queries are happening and stuff like that. And then the new one become we don't call it slave. I don't know how we call it today. A secondary will eventually get the same data from the primary, right? In case that it needs to become a primary. So primary would have the responsibility of both serving the data and also pushing data to the new secondary. Is that more or less?
Yeah, so actually, the only thing is when I say replica is like volume replica, it's not the database replica, because what we didn't state is there's two levels of replication, of course, when you're talking about the database. There is the application level, so you also have database replicas, which is one thing. It's really at the application level that you're replicating, and then you have the storage, the block level, like the bit level, if you like. So this is what we are talking about now, and this is exactly that. So on a per volume base, if I take the example of what we are doing, every volume has its own little brain that is dedicated in the control plane. We call this disaggregated consensus, which means that any volume can make decision on its own independently of the other volume. So for every volume, you will have a primary and secondary replica placement that is managed by our data mesh, our engine. And once you start writing data to the primary, you have exact copy at every point in time, right? And it's just about shifting to another volume, to a replica upon failure, and attaching that volume to the pod. So it will have exactly the same data. Now, one may ask, if I already have replica, like at the database level replication, do I need volume-based replication? Yeah, because you don't want to start with an empty disk, right? So the data is still there and you just continue to run. Now, there may be a situation where the scheduler is going to say, oh, I cannot schedule this stateful pod on the node where there's any volume available. There's no volume available on the node where the pod is going to be rescheduled. So on top of that, and this can happen. So if you want to prevent that situation, you need a way to provide a remote access to the volume, but still having the pod thinking it's local, right? And actually, this is also what we do. So that even if bad luck, you cannot schedule the pod on a node that has a volume, you can remotely access another node that has the volume. You may have some degraded performance depending on your network, of course, but it's still better than, not running the pod at all.
So it's then, I guess, so replication is happening at the volume level, right? Not database level. And then that new replica of a database is basically being, am I wrong if I say that new replica is in the pending state, is not really starting until the data is there somehow, right?
Exactly. It's consume space on a, somewhere in it's a blob file that we create that will have the data. And it's just sitting there on the node. And from a Kubernetes perspective, it will only be visible in case of trouble, in case you effectively have to promote, not you, but in case the engine is promoting a new replica as primary volume, then you will see it in Kubernetes and you will see attached to the pod. Yeah, that's correct.
It's in a way like a mini scheduler for volumes, right? That figures out where to put it, how to put it, and stuff like that.
Yeah, exactly. It's and this is why we call it the data mesh, is because it's connecting every node and kind of aggregating the total disk space. But on top of that, it's really considering this whole storage space as a mesh. Like as soon as you have a failure, let's say if you had configured 3 replica total, so 1 primary and 2 replicas, is if you lose the node where the primary is. So we said that a new replica is going to be promoted, but remember that we should stay to 3, right? So at the same time, we will start another replica somewhere and start syncing the data. And our solution is really optimized for fast delta sync. So you will find that even with large chunk of data, it's going to be quite fast. What we want to do is basically not let the user be in situation where your nominal operation, where you just recovered, but you're still missing 1 replica, right? So you need to go fast to the situation where if you have a second failure, you still need to have this global amount of replica.
So data is, when you're restoring data in a new volume, it's traveling through the network, I'm assuming, and getting there. Would that potentially affect other applications from the networking perspective? Would kind of like such an operation put whole networking in trouble, or?
Yeah, I mean, it can. It's always the same consideration for synchronous replication, which means that the performance, even writing to your local disk, is limited by your network because it's synchronous. You need to get the ACK, the acknowledgement, from the replicas. So you cannot write faster than you get the acknowledgement. So even if you have like a super large pipe to write to disk and a very small pipe to write to your node sitting next to you, you will be limited by this little pipe, right? So that's the first thing. You're limited. It's not proper to, it's always, you have to choose, right? It's a trade-off. If you want synchronous replication, well, you're depending on how fast you can synchronize the data with your peers, right? Regardless of your local drive performance. That's one thing. And second, you are sharing, the network is a shared media. You're right. So you are sharing networking with other applications sitting on that node. So potentially, yeah, so what I recommend usually in Kubernetes is, Kubernetes is easy from a networking, not easy, but I would say it does provide simple paradigm in terms of networking implementation. So there are basic rules like every pod should be routable, etc., etc. So you want to manage how large your network pipe are by doing things like bonding or at a channel, bundling network cards together to give you more power. So you add more than 1 card to give you more potential entropy so that you can both have this replication happening while at the same time serving your, networking and serving like just the user network, or people who want to access pods normally, or pods that, microservices that need to talk between each other. So yeah, network becomes also kind of a bottleneck. So when you start doing storage and replication and running stateful application, you also have to potentially increase the pipe for your network. Yeah.
But then I guess that if you focus now only on stateful applications, I'm ignoring the rest, right? Should people run in multi-zones or single zone? I guess with single zone, you have no fault tolerance, right? Multi-zone would increase potentially the transfer issues, or am I wrong?
So let's consider this one, right? So if you are in a hyperscaler like AWS, of course you want to have your nodes in more than one AZ. That's a given. Now there's, I would say, 2 types of approaches that you can have. So you can say, okay, I'm going to have a single Kubernetes cluster spanning more than one AZ, right? And potentially, let's say I'm going to use a solution that does synchronous replication. So guess what? You're going to have cross-AZ transfer, which also transfer into increased cost. But again, it's a trade-off between your requirements in terms of high availability and cost, right? So that's one. If you have synchronous replication, you will have data crossing the AZ. So you have to evaluate how much data that is and potentially the cost. Or you can say, oh, I'm going to keep my cluster just local to my AZ, and I'm going to use asynchronous replication. And it's going to be a second cluster. And then you have all sort of other concern or considerations. And so how are you going to asynchronously replicate this? Are you going to use snapshots? And then again, we need to quiz the application. And then how are you going to recover at the destination? So yeah, it's either one big cluster and synchronous replication across AZ, or smaller, cluster, but individual cluster, one per AZ, and then, a different way of replicating asynchronous, which also means your RPO and RTO will be different. Like that won't be a 0 RTO or 0 RPO, right? So I would say you have to find the right balance for your requirements. What I see the most really in terms of, I would say, design patterns is to have cross-AZ Kubernetes cluster, because we have the topology key, and cloud providers, typically they populate this field. So for people who don't know, the topology key is just like a Kubernetes, let's say, sort of annotation that tell where your nodes are. Like, for example, if you say topology key US West 1, then all Google, if your nodes are there, all the nodes will have the topology key set to US West 1. And then for the same cluster, the nodes that are in maybe US West 2 will have another topology key, which will be US West 2. And this particular field can be used by external system to take decision, like replication and where to place replicas, these kind of things.
How about cross clusters? Is that a myth? Does that work?
I don't know. I never did it. But apparently, to be honest, yeah, I keep people are talking about it. Yeah, you can replicate and just you have your manifest that just restarting on the. There's two things. You need to have the data and you need to have the manifest. So the data is there. That's fine. But how do you do that? How do you configure? I would say, how do you in terms of power? How do you design your destination? Is your destination cluster empty? Is it already running something? You have the data there. How do you create your pods there, right? Because the data is something, but you need all the configuration, all the manifests there. So it needs a lot of glue, in my opinion. Like if I had to do it, man, it would take some time. So I needed to first just build the right cluster with the right size. And do you really want to have like, let's assume that, okay, it's going to be hot standby. Well, what are you doing? Is you just paying money and running nothing? Or if it's running something, how do you guarantee that what will be the impact in terms of performance of the existing workloads, and how do you prioritize them? Because Kubernetes has some rudimentary way of guaranteeing resources, but it's not the same as vSphere and VMware Resource Scheduler, where you have this very complicated algorithm to calculate how you assign priority dynamically and all these kind of things. This really doesn't exist in Kubernetes. The system is much more simple in terms of reserving just resources in the cluster. So there are a lot of areas that for me are a big question mark. I've done a lot of VMware cluster design in my past life. So and that was a long exercise to design the right cluster and design it for recovery. So for Kubernetes, I can't imagine to do that, to be honest.
I think it's more about people jumping into all the buzzwords. Similar like multicloud. I'm a huge believer of multicloud, just to clarify. I think that that's a thing, but not for the same thing. Kind of when I hear multi-cloud, I'm going to run my Kubernetes clusters both in AWS and in Azure, I freak out. Now, if somebody tells me I want ML ops in Google and something else in AWS, to me, that's perfectly fine. But multi-region, multi-cloud for the same thing, whatever that same thing is, sounds like somebody who is going to spend a couple of years and a lot of budget to find out. It doesn't work.
Yeah, my perspective on multi-cloud, multi-cloud is a thing for sure. Just because it's not a decision made by engineers, it just happens as a consequence of a merger, or as you said, you have the right tool for the right job in different clouds. So go there, but running the same application in different clouds just for the sake of it, or because a cloud may be down seems a bit extreme. Although I would say, depending on your experience, like if you have your application in maybe multi-region at least, like multi-region, I can understand if you have an AZ or the whole region that goes down. Yeah, that's all right. Or it can be, let's put this way. Imagine that from a business perspective, you absolutely need to sit in a particular region. So choice one, you go AWS in that particular AZ or region. And if you don't trust that region, what are the other alternatives? You want to stay in that region. So the only way is to go in another cloud in that region. I mean, that's a bit of a corner case, but that would be, I would say, maybe a reason to do it if you're gonna go like completely, you have OCD about failure in AWS and you may fear for a whole region to be down. I mean, that would translate into the whole, even like multiple, one big data center to be down. So maybe, different provider, same region. I don't know, but if it's just for the sake of it, and no, that's too much because you need to change the skill set of people. If you have people already, in the company following a merger or whatever acquisition, if you have different skill set, then that's fine. You can use multi-cloud. But if you're a single cloud and suddenly you decide without region to go to a second one, it's just hurting, like shooting yourself in the foot. That doesn't make any sense. Not at all. I agree.
Let me jump on the back of this whole multi-AZ region cloud conversation. One of the things that comes up anytime you bring in primary and replicas is split brain. How do you deal with split brain?
So that's an interesting question. In the case of Kubernetes, you have to reconverge, right? You have a node down is coming up. What's happening? Well, you have pods running because the way Kubernetes work is completely asynchronous. At some point, it will reconcile the current situation, right? So in Kubernetes, generally, because it's been kind of designed for that, you should be in a bad spot when a node is recovering. Now, if you have a solution like us, yes, definitely, because we are doing things synchronously. If a replicas go back up, what's happening? If it was the master or the primary before, how do you ensure that this guy is not going to claim his due? Basically, what we are using timestamp, essentially. So because time is the only, I would say, parameter that will tell you if you're entitled to reclaim your position or not. So typically, we're going to go deeply into storage. I hate to talk about storage, but just for 5 seconds. So for every block, we will have metadata with timestamp. And for everything we replicate we'll always have a time value. So when you look at the primary, the old primary, which is coming up, you will see that if it's trying to join, you will see that it cannot be master again because all of its data is completely, old. So we cannot claim that position. So this is how we solve this split brain, saying like, no, this guy is it's too old. Like it's not going to work anymore. We'll leave it there. And this space can be reclaimed by something else. And you can start replicate again towards the node. Like this space that it was consuming is just given back to a potentially space where you can replicate data. Yeah.
But in that scenario, from now container perspective or pod perspective, ignoring volume, right? There is nothing telling you that, or I might be wrong, right? But Kubernetes itself might decide, okay, now you had 3, now you have 4. Even though you want 3, I'm going to shut down one of those 4. And that could still be any of them, right? And not necessarily, or am I wrong that...
For StatesfulSet or for deployment, typically... so if for deployment, let's say, so typically you have this 5 minutes grace period and the pod, if the node becomes isolated in Kubernetes, then compared to the master. So let's say it's a worker. So the master will see that the node is not there. So after 5 minutes, it should remove the pod from the running pod. So you should not be able to see that. It should be killed. From a master perspective, if you do kubectl get pods, you should not see this pod after 5 minutes. And when the node go back, the node typically will see that the master doesn't have this pod running anymore. So this pod should not be restarted again, right? For stateful sets, we have a feature that will kill the pod on the partition node a lot quicker. So it's called fast failover or fast failure, something like that, because we have this data mesh that is always talking to each other, which is also using Raft. I mean, the classical, distributed system. We have this kind of keep alive. We can shoot the pod a lot faster. And because then it's up to the control plane, right? If it's shut there, then the master will still have the same thing, right? The pod is not there. When the node comes back, then the pod won't be starting on that node anyway. So you should be, I would say, rather in a safe situation. But what you want above all for StatesfulSet, you want to fail over fast. So typically, I mean, if you use Ondat, we will do it for you. You just enable, again, using an annotation, fast failover, or it's called fast fencing. Can't remember the name of that feature. But we'll detect it a lot faster for you, making the whole process a lot smoother, I would say. Yeah.
So we've gone from losing our storage, losing our pods. We've gone multi-AZ to region to cloud. Yuck. What else is going to be happening with storage in the next 5 years?
Yeah, so I see storage, not especially in Kubernetes, the right way to consume storage is not to talk about storage. So I would say where storage needs to go in Kubernetes is closer to the developer, right? This is related to what I was saying before. You want to expose as many things as possible natively in Kubernetes, just using things like annotation and being integrated into pipelines and the whole idea of shifting left, which means that giving storage as a on-demand resource to developer. It's like software-defined networking a couple of years ago. In the world of Kubernetes, you don't want to wait for admins like storage admin, network admin, or cloud admin. You don't want to wait for them to provision what you need because it completely destroys the purpose of Kubernetes, which is just on-demand everything. Like you have pipeline that are deploying your application into production using GitOps or any CI pipeline, really. You want storage to be part of that too, so that you can start very early in the development process to use the right features for the right job. So for example, let's say you're a developer developing a, let's say, performance sensitive application. So very early in the process, you need to be able to profile what kind of performance you can reach on your storage. So which means that you need potentially to enable those production feature that you will have running in production for your application as early as possible. So for example, synchronous replication can impact your performance. Things like, the type of disk you want to have, all of that you may want to test as early as possible. So therefore, you need to apply those DevOps principle to storage as well, which means the storage you're using must be compliant with those principles, which means that Kubernetes, you need to be able to support infrastructure as code, all of that. Where I'm going with this is, for me, in the next 5 years, storage should really become commodity for Kubernetes. So having more and more feature inside Kubernetes. So today, as I said, we have replication, we have a bunch of feature outside of Kubernetes into the CSI. I think what is important is in the next 5 years, we have more standard in Kubernetes to easily plug those kind of features. Today, every vendor, every solution has its own things. And you can see same thing with the network. At the beginning, there were a lot of different service mesh. Now we tend to standardize with metrics, with security. And I'm expecting the same thing with storage as people will run more and more stateful application in Kubernetes. So what I'm expecting is more and more customer run stateful application, and that's storage function are closer to DevOps paradigm. And in the Kubernetes, I would say community, we'll see more and more activities happening, like the DOP, so the data on Kubernetes community. I think it's something like 1.5 years old, which is quite recent in the world of Kubernetes. And, I'm sure we will drive a lot of effort to kind of also bring more standard directly into Kubernetes in terms of what you can expect from storage. Yeah, so I'm expecting also, I would say like legacy storage vendor, either through acquisition or through innovation, they tend to bring solution in Kubernetes as well. But I would say it's not necessarily the best ones because they are making business out of, still hardware boxes. So, but full software solution, like Maya Data, OpenEBS, us, I think we are bringing more innovation to the picture, and I think it's a good thing for even those legacy vendors who are, acquiring those companies, which is good. But yeah, the landscape is going to continue to change, moving away from the old, legacy storage towards more of a hyper-converged. So you had hyper-converged for virtualization with Nutanix vSAN that came, a long time, probably like 10 years after virtualization had really started. And the same is happening with Kubernetes. Kubernetes started without really thinking about storage. And now we are entering the world of hyper-converge, where you can just use the local drive in Kubernetes or your EBS drives in Amazon and Google persistent disk in Google, etc. So yeah, it's just becoming a commodity, and all the feature, the function are now happening purely in software. So there's really a decoupling between the hardware and the software solution that is, very, very much Kubernetes. And this is, I think, where we're all going.
Well, Nic, if people want to get in touch with you, what's the best way to do that?
So I would say easiest, you can find me on Twitter, which is @Nic Vermandé. And second one I'm using a lot is LinkedIn. So Twitter, LinkedIn, and the third one, we have a Slack channel. I can't remember the name of the public one. You can find it on our webpage, ondat.io. So you can join the Slack channel from there. And yeah, I'm just hanging around here all day long. So if you want to get in touch, Slack is also a good option. So Slack, LinkedIn, Twitter. That's probably the three best way to reach out to me.
And I'll make sure all that information is down in the show notes. Nic, thanks for joining us today.
Thanks very much for having me. Really enjoyed it.
We hope this episode was helpful to you. If you want to discuss it or ask a question, please reach out to us. Our contact information and a link to the Slack workspace are at devopsparadox.com/contact. If you subscribe through Apple Podcast, be sure to leave us a review there. That helps other people discover this podcast. Go sign up right now at devopsparadox.com to receive an email whenever we drop the latest episode. Thank you for listening to DevOps Paradox.